All right, hello and welcome to our first session of the bootcamp. So let me share my screen. Wait for it. All right, let's see, can we see? All right, so let's test if the chat function is working, if you can see my screen, just while we wait for maybe 1 or 2 minutes while people join. Just answer in the chat on a scale of 1 to 5, how confident are you feeling with the topic that we're starting with of binomial distribution? So 1 to 5, 5 is high, just let me know in the chat function, and then we can get going. All right, it's working. I see 3 out of 5. All right, that's a good start. Give it maybe 1 more minute. All right, I think we'll start. So welcome to our first session. Just to introduce myself, I am Ashley from Miss IB Maths, collaborating with Exam Dojo, Ashley. I'm an IB teacher, tutor, and an IB examiner. So in the session, we're going to be just looking at a few, just a refresher of binomial distribution, a couple of definitions, formulas, etc. Then we'll do some worked examples, and then we'll have some exam questions going through the exam mark schemes, and then some questions at the end. All right, so let's begin. And if you see a box like this, the blue box with the orange, just that means it's a question to answer in the chat. So if you see that, you can go ahead and answer. Also, if you want to grab a paper and pen and your calculator so that you can take notes as you go and follow along, try the questions, I also recommend that you do that. All right, so just to get into the zone of mathematics on this Saturday morning, can you answer this question? So state whether a binomial distribution is a suitable model for the situation. So a bag contains a large number of beads, 40% of which are red. 10 beads are drawn at random, and X is the number of red beads. Does this situation follow a binomial distribution? Answer yes or no in the chat, and if no, can you give a reason why? If you're not sure, we're going to go over what the criteria are for it to follow a binomial distribution. But if you have any ideas, let me know. All right, so the answer here is yes, it does follow a binomial distribution. So we had a fixed number of trials. So there were 10 beads are drawn at random. So that was our 10 trials. The bag contains a large number of beads. So if we're drawing 10, that doesn't change the proportions. So trials are approximately independent. Then there are 2 outcomes, 2 chances that we have success or failure. So if we take out a red one, that is success. If not, it's not red, which is failure. And the probability of drawing red is constant. Each time you take it out, there is a 0.4 or 40% chance of it being red. All right, so it meets all 4 of those criteria. Therefore, we can say it does indeed follow a binomial distribution. All right, but we will go through that a little bit more. So let's start with the definition. So binomial distribution is a discrete probability distribution that counts the number of successes in a fixed number of independent trials where each trial has only two outcomes, success or failure. So binomial, bi meaning two, we either have success or we have failure. That's all we're interested in. We're not interested in all the probabilities. So if we have a bag of beads, say we have red, we have blue, we have black, we have green, we're not interested in all four of those colors. We're going to pick one color, so red in this example, and if it was red, that's success. If it was any other color, i.e. not red, then that is failure. All right, so that is how we're going to define a binomial distribution. Just a bit of notation. So we say x, our variable. In the previous example, that variable x, the chance of success, was drawing a red bead. That was our variable x. And then little squiggly line here says it is distributed. So our variable x is distributed, b for binomially, as opposed to n for normally, with n being the number of trials. So in the last one, we had 10 beads, so n would have been 10. And the probability of success, because we're interested in success, and that was 40%, or 0.4. So all of these things make a binomial distribution. All right, so just back to those criteria, because this is a very common way that a binomial distribution question starts out. They'll start by saying something like, is this scenario following a binomial distribution? Or state two of the criteria that shows this follows a binomial distribution. And that's generally quite an easy 2 marks. All right, so if it follows all four, so number one, there is a fixed number of trials. That's always going to be our n value, the number of times that we do something in the experiment. Each trial has to be independent. So each time we take something or each time we do the trial, it doesn't have any effect on the next trial. So they mustn't have an effect on each other. Then 3, there are exactly 2 outcomes. Like we said, binomial, we need 2, success or failure. When we're talking about success and failure, we don't mean it in a real world sense. We're not looking at something successful in a real life situation. Success in a binomial distribution could be also defective light bulbs, for example, the chance of something not working. That could be the thing that you're looking to find. And so for the binomial distribution, that would be our success. So it's just important to not think of success as being a necessarily good thing when you're defining a variable. So success is basically just whatever you're trying to find. And that is usually given quite clearly in the question. All right, then the last one, probability of success, that's our p-value, p for probability, is constant for every trial. So that just means that it doesn't change from trial to trial. So each time it's going to be the same. If it meets all 4 of these criteria, then we know it is a binomial distribution. All right, before we move on quickly, let's just have a look at the formula booklet and what formulas you're given. So I would recommend when you're doing your exam to have your formula booklet open to the topic that your question is on. This just helps to have everything there and clearly ready for you when you're doing your exams. You don't have to think about anything. Also, if you're looking at those formulas before, it might give you a little bit of a hint as to what you might need for the question and just remind you what you have there, some words and things coming up. So I really recommend having it open to the topic that you're on for that question. All right, so binomial distribution, we have that x is distributed binomially with n and p. This is helpful in case you forget which order. Was it n first or p first? So that's nice to have. And to remember that each question, you're going to need to write this. A lot of the questions you're going to be doing on your calculator. So if you're wanting to get those method marks, you really have to show this. You need to write that down and show that you understand that it's a binomial distribution. And it's something to get those marks. We'll have more of a look at that later. All right, then we have the mean. That's our expected value. Let's write that. That was our average, mean, expected. So we're going to be looking for the word expected or expect. What can we expect to find? That's a clue that we're going to use this one. And the variance. So variance is standard deviation squared. And we're going to look more at those examples later. So in the chat, what formulas do you need to memorize for this topic? So if you have a look, this is all you're given for binomial distribution. Is there anything else that's missing that you need to memorize, that you need to understand or you need to know before going into the exam? Answer in the chat. It's a very quiet chat. Don't be afraid to get something wrong or to try and guess. This is a safe space. All right, so the formula that you need to know is this one over here, the binomial distribution formula for probability. So the probability of getting exactly R successes in n trials. So this is what your calculator is doing when you click on binomial PDF or binomial CDF. It's doing this formula and finding that out for you. But for some questions, you may need to use it. It's not always that it comes up in exams, but it can happen. Most of the time, you will be using your calculator to calculate the binomial distributions. But sometimes they may, for example, ask you to find n. So they might give you the other information, and then you have to work backwards to find n. So that's where this formula will come in useful. So write it down and make sure before the exam you've memorized that. Does it look familiar, by the way? Do you recognize any other formula that looks very similar to this? So this is very similar to the binomial theorem. So that can also help you, but just keep in mind that these would be the other way around. All right. So let's look at those formulas. We have expected value, the average, what we can expect to see. This is taking a probability and turning it into a value that we can use in a real life situation to say what we expect would happen if this trial happened. All right, so n, number of trials, p, probability, which is great if you have already calculated or written your binomial distribution like this. You'll already have n and p. So all you need to do, multiply them together. So expected value questions, very nice questions. Similarly, for variance, it's n times p times 1 minus p, the complement of p. So if p is our success, then 1 minus p is the complement of that. That's our failure. So probability of the thing we want happening times the probability of what's not happening. So let's say if p was 0.7 and our trials were, let's say, three trials, probability of happening is 0.7. Well, the probability of them not happening, they've all got to add up to 1, is just 0.3. So when we have this information, we have everything we need to find expected value and variance. And if you're trying to find the standard deviation, all you need to do is square root that answer. So what we have here, to get the standard deviation, we just need to square root that value. And there we have standard deviation from that formula. So just remember those. All right. So setting up our model, identify what the trial is. That is usually quite clear because they'll say they're going to do this thing 30 times or they'll perform an experiment 10 times. So that is often very clearly given. Identify the successful outcome. So this is quite important to knowing what you're trying to look for and to help you answer questions that come later. So the successful outcome is whatever we're looking for, and that will always be our variable x. So x is, in the last question, for example, the red beads, something like that. That could be you identifying your successful outcome. So taking out a red bead. Then parameters, just to go over this exam word. Parameters are the things that could change depending on the situation. So n is our first parameter and p probability is our second. So remember that's part of what we're writing here. So that would be identifying your parameters. And then clearly state your random variable. So just like we had here, x is the whatever random variable is. All right, I think it's time for some practice. All right, so just like our warm-up question, does it model a binomial distribution? So now that you have been reminded of those 4 conditions, I put them here as well for you. Does it model a binomial distribution? So an archer shoots 12 arrows at a target. First hint there. Ooh, 12 arrows. So he's doing it 12 times. So n equals 12. Highly recommend when you're going through your question, writing out the things that you are figuring out. These are all clues. Each shot hits the bullseye with probability 0.35. Lovely, very clearly given. We don't have to do much work there. Independently, oh, there's that keyword, independent. Oh, didn't mean to cross it out. Independently of other shots. Let H be the number of bullseyes. So that is H be the number of bullseyes. That is our variable that we're starting with. What would success look like in this situation? You can answer in the chat. What would be a success? What are we looking for? Very nice. I see it in the chat. Hitting the bullseye. Indeed. So our probability of success is getting a bullseye or not getting a bullseye. So I'm not very good at archery, and I'm not sure what other outcomes there are. There's all the different numbers, aren't there? But we're not interested in anything else other than bullseye or not bullseye. So, right, let's see. We have fixed number of trials. Yes, n equals 12. Each trial is independent. So they've said independent, so we know that. That was nice and easy for us. We've got that there. But if you think about it, if I'm an archer and I'm taking shots at a target, the one before doesn't affect the one that comes afterwards. So none of my shots are going to have an effect on each other in this trial. I mean, maybe my mood, depending on if I'm getting it right, might change a little bit, or depending on the situation, but generally they're not going to have an effect on each other. So they're independent. All right, there are exactly 2 outcomes. So remember, when we're shooting arrows at a target, there could be multiple outcomes, but what we're interested in is it is a bullseye or it's not a bullseye. So those are our success or failure. And success could also be the number of not bullseyes if they said that that was our variable, which in the real life situation would be a failure. But just to remind you that it depends on what they say. So here, let H be the number of bullseyes. That is the outcome that they're interested in. All right, then the probability of success is constant for every trial. Yes, P equals 0.35. Each time, that is our probability. So it's not changing. All right, so yes, we can say it does model a binomial distribution. And let's write it out. Usually you should end with saying this. Yes, it's a binomial distribution. And, oh, sorry, we actually are not with X. They've told us it's H. So our variable H is distributed binomially with n equals 12 and probability 0.35. All right, and then you would have a mark for showing that. That shows that you understand it's a binomial distribution. All right. So a gardener plants 15 tulip bulbs. Hopefully alarm bells are ringing. You think, oh my word, n equals 15. From past experience, each bulb has an 80% chance of blooming. Okay, there's a probability there. So P equals 0.8. We like to put these in decimals. It will still work if you write 80%. Just don't forget, obviously, to write percent when you're putting it on your calculator. Independently, great. So we know so far that it's a binomial distribution. Let X be the number of bulbs that bloom. Okay, so success for us is a bulb blooming, and failure would be not blooming. So again, explain why it can be modeled. We have a fixed number of trials. Each trial is independent, 2 outcomes, blooming or not, and the probability is constant. All trials met. Okay. Let's go to B. All right, find E of x. That was our expected value. Let's start by writing that we have x is distributed binomially with trials 15 and probability being 0.8. All right, so expected value was just number of trials times probability. So 15 times 0.8. Anyone with some quick maths there? All right, the answer is 12. So we can say that out of 15 tulip bulbs, we can expect that 12 are going to bloom. Then variance var x was, just going to move that up, n times p times 1 minus p. So n was 15, p was 0.8, and the probability of it not happening, the complement of 0.8, 0.2. Make sure, remember that they add up to 1. All probabilities add up to 1. And if we do 15 times 0.8, well, we know that that was 12. 12 times 0.2 gives us 2.4. All right, those, if you get them, expected value and variance, those are quite nice questions that are some easy marks. Make sure that even though this formula is so simple, you're just doing that, make sure that you show that calculation. Don't immediately just go and write 12. You should show this calculation. Again, so many of these questions will be done on the calculator, so it's really important to write out as much as you can. Really show all of your method steps, especially for these kind of questions, especially for any questions that involve substituting into a formula. It is very good practice to set it up, to write out the formula, to then substitute your values, and then to write the answer. This also helps just to make sure that you don't make any mistakes, that you don't remember or not remember the formula correctly when you're transferring it. It's often a high-stress situation in the exam, so even miswriting the formula or looking at the formula, typing on the calculator, a lot can happen. But if it's all there and you're taking it nice and logically step by step, then you have less errors. All right. Let's do one more worked example, and then we'll move on to the exam past paper questions. So a multiple choice quiz has 8 questions. So what are we thinking? Alarm bells ringing again. 8 questions. That means 8 trials. N equals 8. Each with 4 options, right? So a multiple choice quiz having 4 options sounds very normal. That's like A, B, C, D. We could have on each question, A, B, C, D, or something like that. A student guesses every answer at random. Let X be the number of correct answers, all right? So correct is what we're looking for. That's our probability of success, is a correct answer. And if you think about it, in a multiple choice quiz, how many answers are going to be correct? Well, 1, right? So let's say A is correct and the rest are wrong. So getting 1 out of 4. So did anyone answer? I think there might be a slight delay, so I might be just getting your answers in the chat a little bit after, but I will keep looking. So what do we think the probability is here? The probability of success. Do we think it's a half? Do we think it's 1 out of 8? Do we think it's 1 out of 4? Answer A, B, or C. All right, so the correct answer is, ooh, it's very small on my screen, 1 out of 4. So because there are 4 options and you can get 1 out of 4 correct, our probability there is 1 out of 4. So don't get confused with that 8 because that's relating to the number of trials. So sometimes a question will look like this, where they don't actually give you the probability straight out. They don't just say the probability is this. So you have to work a little bit harder just to have a look at the situation, try and draw it out, try and think of it as a real life situation. Like what does typically happen when you're taking a quiz? What are the probability that you get a question right? And yeah, don't forget to write your probability. So let me just clean this up a little bit. All right, so P equals 1/4, 0.25. All right, let's write our binomial distribution. X is binomially distributed with 8 trials and 0.25 probability of success. Great, so we know it's binomial distribution, and we've got all of our parameters, which is lovely when they give that to you. So exactly 3 correct. Exactly 3. We want 3 questions that we got correctly. We're going to write it like this. The probability that X is equal to 3. Exactly 3. We want just that 3 number. All right, so we have our formula here. Let's practice putting it into the formula. So we have N choose R. So our N was 8 trials. R being the number that we want, so 3 in this case, times the probability, so 0.25 of 3 correct, times the complement 0.75 of N minus R, so 8 minus 3. And that's how it would look if we're substituting in. We need our R, so in this case, getting 3 correct, the value that we're trying to find, what we're interested in, our P probability, our N, and our converse probability, our complement. So just those things are what we need to substitute into here. And then you can see it's actually not such a bad formula after all. Looks like a lot is going on over there, but it's not so challenging. So if you put this into your calculator, you would get the correct answer, and you can put that whole thing on your calculator. Remember this 8, 3, N choose R, N choose R. Could also look like this, N choose R. You might have seen it like that, or where the N is down there like that. Typically, I think we've been using this and this in your exams, but sometimes this one pops up as well. And that formula, just in case you'd forgotten that, was N factorial over R factorial, N minus R close bracket factorial. So we could also calculate it using that or with our calculator, depending on the question. But let's have a look at what that looks like on your calculator. All right, so we were interested in finding binomial distribution for one value. So we're going to click menu. Now, if you see here, we have probability distributions. That's what we want. You can also find that in statistics distributions. It's the same thing. They both take you to the same place. Then we scroll down. We want binomial PDF. So PDF is when we're just looking for one value, one exact value. So binomial PDF, number of trials was those 8 questions. Probability of success was 1/4, 0.25. And the X value we were interested in was at exactly 3 correct. So at 3. Let me press OK. And it looks like this. We get binomial PDF, 8 trials, 0.25 chance probability, and the number we're interested in, 3. All right, so we have 0.2076. We want 3 significant figures, so 0.208. So let's write that there. Just going to take this away for now. Let's clear up some space. Other questions. All right, that was 0.208. Double check, just like you should in the exam. Did I round correctly? Did I write it correctly? A lot of students often miswrite. Like they've got all of the perfect formula, everything was done perfectly, but then there's a miswrite. So double check, 208, perfect. All right, so exactly 3 correct. Now, at most 1 correct. So if we're thinking about this as being discrete probability, discrete values of x, we could have values that are like 0. Don't forget 0, we always start at 0. You could get no questions correct as well. 0, 1, 2, 3, all the way to 8. That's how many possibilities we have of getting something correct, because we have 8 questions. All right, so if we want at most 1 correct, at most 1, that's meaning values of x are going to be 0, 0 is at most 1, and 1, that includes 1. So what we're looking for here is the probability that x is equal to 0 and the probability that x is equal to 1. That's at most 1 correct. All right, so that's what we want to find. Luckily, our calculators can do binomial CDF. So where we do cumulative, because that was 2 different values. So instead of writing x equals 0 and x equals 1 and finding both of those and adding them together, we're just going to say find the probability that x is less than or equal to 1. So less than or equal to 1, that's already assuming, because we're in a binomial distribution, it's starting at 0 and the next value would be 1. So just taking those 2. X is less than or equal to 1. All right, so again, we can go to our calculator. If you're not sure, if you don't remember where to find things, all good things happen at menu. And probability or statistics, distributions. We want binomial CDF. See the difference there? They look very similar. PDF, that was for exact, where we just want 1 value. CDF, C stands for cumulative. So if I want to have more than 1 value, or a range, or less than something, or more than something, I want that cumulative. So CDF. Number of trials was 8. Probability of success was 0.25. My lower bound, what is the lowest value I have? Well, 0. And my upper bound, I wanted up to the value of 1 and including 1. All right. Oh, where did it go? Did I click cancel? Oh, strange. All right, so we wanted binomial CDF, 0. No, number of trials was 8. 0.25, lower bound, upper bound 1. There we go. All right, 0.367. 67. So 0.367. It's everywhere. And double check. Yes, we have rounded that correctly. All right. Next one, more than 2 correct. All right, more than 2 doesn't include 2. More than 2 correct starts at 3. So if we have 0, 1, 2, 3, 4, 5, all the way to 8. More than 2 are these guys over here. We're not including 0, we're not including 1, we're not including 2. So we want 3, between 3 and 8. So we can write that as the probability that x is between 3 and 8. And we can do that on our calculator. Another way that you can do it is you can find the probability of this, 0, 1, and 2, and subtract 1 from it, because that will give you the rest of what is over there. So you could do that as well. Just find those 3. So from 0 to 2, and then subtract 1. Both methods fine, both methods work. This way is probably less steps and a bit easier. All right, so we want between 3 and 8. That's more than 2 correct. So again, we go binomial CDF. Now, a little shortcut that you can do is scroll up to that. You don't have to go through the whole menu again, because you've already typed it. So we have binomial CDF, just double check. Yes, my number of trials was 8. My probability was 0.25. And I now wanted to go from 3 to 8. So that I just need to change those 2. All right, and we get 0.321. What a nice answer. 0.321. All right, and there we go. So these exact ones can be calculated with the formula or with your calculator. These ones way easier to calculate with your calculator, because if you use this formula, it's for values that are equal to. So you would have had to do probability that x is equal to 0 plus the probability that x is equal to 1, add them together. So this whole formula for x equals 0, the whole formula for x equals 1. This one would be even more. X equals 3 plus probability of x equals 4. And I'm not going to write all of that out, but all the way to 8. So thank goodness for our calculators. And that's also why in exams you're most often, or almost always, going to be asked to use your calculator, because that saves a lot of time and effort. All right. Let's go on to our first exam style question. So what we'll do is we'll go through these and try them, and then we'll have a look at the mark scheme next and just see where we're getting those method marks, what we need to show. It's especially important for this topic because, like I said, so much is done on the calculator, so you need to show that you understand. If you just type in your calculator an answer and then write it in your on your paper, there's a chance that you typed something wrong, you understood something wrong, and the whole thing is wrong. Even, you need to show that you understand what's going on. So remember that you're always going to write, as soon as you know all the parameters, x is distributed binomially, and p, and insert your values of n and p. That's just pretty much always going to give you 1 mark. And you'll see that they often are giving you a mark just for recognizing that it's a binomial distribution. So just writing this, even if it was wrong, if you have recognized that it's a binomial distribution, you get a mark. So that is great. So it's good to show that. All right, let's see. What do we have here? This is from the specimen paper, just so you know. It's paper 2 as well in the SL. So a 6-sided biased die is weighted in such a way that the probability of obtaining a 6 is 7 out of 10. Let's take some time just to break that question down. Sometimes they can be quite overwhelming and you're like, what do I need to find? What are we looking at? So a 6-sided die, all right? We have on a 6-sided die, 1, 2, 3, 4, 5, 6. I know this seems quite obvious, but sometimes it really does help when you're trying to pick out the questions, figure out what they're asking. So it's 6-sided. It's a biased die. Anyone know what biased means? A biased die. So biased die as opposed to a fair die. So if I were to take a normal fair die, which is what hopefully most of the ones, if you've been playing board games, have been a fair die, that means there's equal chance of getting any of these numbers. Okay, so 1 out of 6 chance for each one. That is a fair die. Now, biased die has something a little bit wrong with it. So it's not an equal probability. It might be more heavily weighted on the 6 side. So it's more likely to maybe to get a 6. So this one, the chance of getting a 6 is not 1 out of 6 like you would expect, but 7 out of 10. So probability is 7 out of 10. I'm just going to write 0.7. All right, and the probability of obtaining a 6. So that is our probability of success. That is our success variable. So x is obtaining a 6. We don't care about any other number. So either you obtain a 6, great, success, or not a 6. So do we have everything that we need? We're missing n. We don't know how many trials. They haven't said that yet, but I can see it's coming up in the next question. All right, so the die is tossed 5 times. All right, there is our n. N equals 5 times. Find the probability of obtaining at most 3 6s. At most 3. So at most 3 could be 0, 1, 2, or 3. At most 3 includes 3. So let's write that there. So remember to say x is distributed binomially, because they haven't actually said that in the question, so you've got to show that you recognize that, where n is 5 and probability is 0.7. Great. And now what we're interested in, at most 3 6s. So px less than or equal to 3. Let's go to our calculator again. We're wanting, let me actually just clear these from the previous question to not confuse ourselves. A new document. All right, probability distributions. I could have also typed it if I want, but I prefer just to write it. So number of trials. We had 5 trials. Probability of success was 0.7. Lower bound, we wanted less than or equal to 3. So we want from 0 to 3. 0 to 3. All right, and we get 0.4717. So we're going to say 0.472. Okay. Great. So for this question, let's just check on our mark scheme to see what we have. There's 3 marks for that, but I hardly did anything myself. So we really need to be making sure that we have that. So let's check out what the mark scheme says. All right. Look at that. Recognition of binomial. So just you writing that, showing that you understand that this is a binomial distribution question, gets you a method mark. Doesn't even have to be correct, just recognition. Then attempt to find the probability that x is less than or equal to 3. Again, just an attempt. Look at this, recognition, attempt, not even correct answers. Attempt to find it. So even writing the probability that x is less than or equal to 3 is showing that you know what you're trying to find. That's 1 mark. And then the final answer here is 0.472. Now, they've also given the unrounded version. Again, because it's your calculator, there wasn't much for you to do, so they've accepted that. They often do that in this case. Always a good idea, I think, to write down this value and then this value. So just to make sure, in case something maybe went wrong with your rounding, or if you need to use this answer later on in another question, you're not going to use the rounded version. You're going to use the unrounded version if you get a question B or C that use this answer. So it's very important not to round too soon or take the rounded version. But for your final answer of each question, you do round it to 3 significant figures. All right, so those were our 3 marks. All right, let's go for B. Has anyone said anything? No. Okay, the die is tossed 5 times. So again, great, let's write in what we have. Tossed 5 times. Same number of trials, we had 0.7. Find the probability of obtaining the 3rd 6 on the 5th toss. Okay, so the last toss, we're going to get the 3rd 6 on the 5th toss. So let's just have a look at what that looks like. Let's say we're tossing 5 times, 1, 2, 3, 4, 5. And they're saying on the 5th toss, I'm getting my 6. So I'm going to write S. S for success, because remember that's obtaining a 6. I guess it can be S for 6 as well, but 3rd 6 is going to be on the 5th toss. Okay, so that's confirmed. What is that probability there? We don't need to do binomial for this. This is just the probability that we get a 6 on 1 toss is just 0.7. So that one we have already. That's 0.7. Now, that means in the previous 4 tosses, there had to be 2 6s because that was the 3rd 6. There was a 6, then there was a 6. We want 3 6s. So one of them is reserved for the 5th toss. So we need 2 6s at some point here. So I'm just going to write success and success there. We don't know when they were. That doesn't matter. In 4 tosses, we had 2 success things. So in a binomial distribution, what does that look like? If we had to write it in as a combination. So our n, our number of trials, is 4, right? And the probability, the values that we're wanting are 2. 4 choose 2. 2 6s in 4 tosses, okay? And let's find that out. So we wanted times the probability, which was 0.7, to the power of the thing that we want, which is 2, r. can just write that formula for you if you want. The probability of x we wanted 2 in our formula was nr p r 1 minus p n minus r. Okay, so we're using that one. Again, we can use our calculator as well, but let's just go through and show this because good practice getting used to it. So not probability of failure, 0.3, n minus r, 4 minus 2. All right, so that is the probability of getting 2 6s and 4 tosses. So we take that. This is 4. I'm just going to take that out now. There we go. Okay, so that was for 2 6s in 4 tosses. And not to forget, we had our third 6 on the 5th toss, and we had that probability. So we're going to multiply independent events. That one. Times 0.7, that probability we had over there. All right, and what we get, let's go and calculate it. 4 choose 2. Menu, probability, distributions. We're wanting CDF. Number of trials, 4 now, because we're just finding this part. Probability of success was 0.7. Our lower bound, we want, we wanted 2. So we want exactly 2. So PDF. Number of trials was 4. Probability of success, 0.7. Swimming in numbers. And the X value we wanted 2. There we go. All right, 0.265. Just going to write that here, 0.265. I'm rounding for my calculation, but when I put them all together, I'm going to take the whole value. So I'm going to just take that value, put it back in, times 0.7. All right, and we get 0.185. 0.185. All right. So apparently on this exam, many of the questions were left blank. So even for SL and for HL, a lot of people were very confused about this. So again, I really recommend that you write out the situation, like really write, okay, so I have 1, 2, 3, 4, 5 tosses. On the third one, I want like really lay it out, put a diagram, think about it in a real life situation. They often sound a lot more confusing than they actually are. And again, practice. The more you do these questions, you see that they're often asking the same kind of things, just in different ways. So once you start being able to recognize how you need to answer it, they get a lot easier. All right. Let's check the mark scheme for that. So we had recognition of 2 6s and 4 tosses. So that would have just been showing your 4 choose 2. That's recognition. Third 6 on the 5th toss. So you would get a mark for this, either the answer that you have or you're working, and then for the final answer. And again, they give it to you without 3 significant figures. You can still get that mark. Very good practice though. Always use 3 significant figures. Let's try another kind of question. So a quick question for you in the chat. Yes or no? When you see this kind of question, does it scare you when you see all of these inequality symbols going on, and there just seems like a lot that's going on there? Does that freak you out at all, or do you know how to approach this question? I'm curious. Don't be shy. Everyone's shy. All right, so this, just to let you know, is from the 2024 May exam paper 2 in SL. Okay, consider a random variable x such that x is distributed binomially with n. Okay, first clue, n. They haven't given us n. We're probably going to need to find n. And probability of 0.25. So p, we know, n, unknown. I like to write up my variables here that I'm expected to know or that are involved in the question, just so I can know what I have, what I'm working with, and what I might need to find. Determine the least value of n, that means the smallest value of n, such that the probability that x is more than or equal to 1 is more than 0.99. Okay, that's a lot to take in. So let's think about that. If we're wanting to go to our calculator and find the probability that x is more than or equal to 1, remember, we're going to need n, we're going to need p, we're going to need a lower value of x, like a lower bound, and an upper bound. Okay, so we have a lower bound, that would be 0. We have probability, 0.25. We don't know the upper bound. X is more than or equal to 1, okay, but we're in discrete variables here. So what value of x do we go up to? We don't know. We don't know how many trials there are. So that's unknown. And n is unknown. So those are two things that we would need to put it into the calculator. Okay, so we know that's your clue. The calculator is not going to help us just yet. What can we figure out from this situation? Let's think about the probability that x is more than or equal to 1 for a little bit. Now, more than or equal to 1, let's think about it. In our discrete, we have 0, we have 1, 2, 3, 4, 5, going up until n, whatever n is. Okay, it could go up for ages. We don't know how that's going to end, but we do know it's going to start with 0 and then 1 and then 2 because we're discrete. We're going in these values of x. So if x is more than or equal to 1, that means that x is all of those numbers. So the only number that's not included is 0. Well, we can figure out the probability that x is equal to 0. We can set up something with that. So if I want the probability that x is more than or equal to 1, I can find that by saying 1 minus the probability that x is equal to 0. So all of them should add up to 1. And if I take away this 1 of 0, I will get all the rest. It doesn't matter how many values of n there are. If I take away that 0, the rest are all included in that value. Okay, so I'm just going to write this slightly differently. So we have, looking at this equation here, probability that x is more than or equal to 1. Instead of x is more than or equal to 1, I'm going to write its new counterpart. Probability of 1 minus the probability that x equals 0. Same thing, right? We've just said that's the same thing. Is more than. Following this, we've replaced this with this. Is more than 0.99. All right. Still unsure maybe what we need to do, where we need to go from here. We need to figure out what's the probability of x equals 0. Again, we don't know n, so we can't put it in our calculator. Let's try the formula. This is where the formula comes in handy. So I'm going to do some working over here. All right, so we have the probability of x being equal to a value of r. I'm just going to write out that formula so you know exactly what I'm doing. And the more you see it, the better. N minus r. All right, so there we have it. So we want the probability that x is equal to 0. So n, don't know. We just have to write n. R, 0. That's the value we want to find. N choose 0. Anyone know what n choose 0 is? I see some answers in the chat of it's freaking me out and it's a bit overwhelming. So of my previous question, I understand that it can be a lot, but we break it down. And yes, I saw someone said that n choose 0 is 1. Anything choose 0 is 1. I'll show you that in the formula. Let's just go n choose 0. Well done, by the way. N choose 0. Let's take it in the formula. So that's n factorial over 0 factorial n minus 0 factorial. That's from our and choose our formula. N factorial, we can't simplify just yet. 0 factorial. What's 0 factorial? Nice. A lot of people think that it is 0, but it's not. It's 1. 0 factorial is 1. N minus 0, well, that's just n factorial. All right, so we have n factorial over n factorial, which just cancel out, and we get 1. All right, so n choose 0 is 1. Then p was, what was our p? There we go. That's why it's good to have it all written out. 0.25 to the power of 0. That's nice. That's going to just be 1. Anything to the power of 0 is 1. 1 minus p. The complement 0.25, that's 0.75. N minus r, and we don't know, minus 0 of our r. Let's simplify and see what we get. So we know n choose 0 is 1. 0.25 to the power of 0, also 1. 0.75 to the power of n minus 0. We can't simplify any further than 0.5n. All right, so this whole thing is equal to 0.75n. So let's go back. We were figuring out this part, right? That was our x equals 0. So now let's put in, I'm going to go back to blue and not overwhelm you with colors. Okay, that was, no. That one, there we go. 0.75n. And we had, not happy with that, how that's looking. Scroll down a little bit. 1 minus 0.75n. There we go. Got there in the end. Okay, so that's just come from that. We've substituted. We still had a 1 minus, and it's more than 0.99. All right. So this is worth 5 marks. This is why there's quite a bit going on here. Again, these kind of questions come up a lot on Exam Dojo, on the learning, on the homework I've given. There are loads of questions like these. So once you've done it once, twice, 3 times, I promise it will become so much easier that when you see these kind of questions, you'll maybe even be excited, maybe, because it's the same method each and every time. So it seems like a lot, but if there's any point where you're confused, just let me know. At the end, once I've gone over everything and we do a Q&A, then I can go back and explain anything that you need. So, right, we're at 1 minus 0.75 to the power of n, and we have an inequality here to solve. Now, let's just solve it like any normal equation, right? I have a value of n there, I have 0.99 there. So I want to join up that 1 and that 0.99. Those are like terms. So what I'm going to do is I'm going to move this 0.75 to the power of n to the other side. So let's do that. It was minus. So that means on the other side, it's going to be positive. And I'm going to move this 0.99 to that side. And so it's going to become minus 0.99. That 1 was just staying there all the same time. 1 minus 0.99. Finally, a nice question that we can answer easily. 0.01, 0.75n. Okay. Now, there are a couple of ways in which we can solve questions like this. This is useful for not just binomial distribution, but many questions that involve inequalities can use this. So you have first the table method. Let me show you that. We want to know when what value of n makes this function be less than 0.01. Okay. So what we're going to do is we're going to go and we're going to create menu. Let's make a new one. I'm not going to save that. Okay, I want to add lists and spreadsheets. Now, this is a really cool method for many, many questions. It's going to help a lot when you need recognizing least value of n or maximum value or things like that. Okay, I'm going to label this. This is my n column. Very important to label these in your calculator. It really helps. This equals bar. Don't put anything in there for now. This is when you want to put a function. So my values of n could be 1, 2, 3, 4. What we can do shortcut. If we want to keep those going, just getting confused, too many. So I take, I think too many things going on my computer. 1 and 2, and I'm going to drag that down for many values, and it's going to put in for me a whole bunch of values of n. You can go really far with that just to make sure you get everything. Okay, so I've got all of that. Instead of going 1, 2, 3, 4, very useful. This is going to be my y, my output. All right, and what I'm going to say is that I want my function to be 0.75 to the power of n. 0.75 to the power of n, because I want to find out what value of n, what of these values is going to give me less than 0.01. Okay, enter. I want it to be a variable reference. So can you see it says n, column or variable? N is my variable. So I want variable reference. And there we go. We've got all of those values. Again, I cannot stress how useful this is for other topics as well. So we have, let's just double check that it did it correctly. There were no typos. 0.75 to the power of, let's say, 1. Indeed, that does equal 0.75. All right, so let's go and have a look. We want, remember, a value that is less than 0.01. So let's go 0. These are still too big, too big, too big, too big. There we go. This value is going to be less than 0.01. So we can write on this to show that if we use the table method from this step, we can say that n equals no, what do we want to say? So we wanted that n equals 17. So that was the value that is less than 0.01. And that is the answer for using the table method. Just quickly, because I'm aware of the time, that there are other methods. So let me go through that. We can use logs, solving by logs. So 0.01 less than 0.75 n. And we just solve this like a normal log. So apply logs to both sides. Log 0.75 n. That helps with that n, because in our log laws, if we apply log, that n can come to the front, which makes things a lot easier. Log 0.01 n log 0.75. Great. Now we can divide by log 0.75 just to get n on its own. So I'm going to divide log 0.01. Now, quick check here. Anytime you are dividing or multiplying with an inequality symbol, make sure that you are not dividing or multiplying by a negative number. If we are doing that by a negative number, we need to switch the sign the other way around. So I've just divided by log 0.75. Is that negative or positive? Well, let's have a look. Calculate. So I want control log. Nope. Control log. There we go. They haven't said a base, so we assume base 10. If they haven't said what base, it's base 10. 0.75. Look at that. It is negative. Okay. So we've just divided by a negative. That means we have to change the sign to the other way around, because we divided by a negative. So it becomes like that. All right, then you would put that on your calculator to solve. Make sure not to round too early on either one of those. And you would get a value that is less than n. And then it wouldn't be exact. So you make sure that, remember, n is only going to be values like 15, 16, 17. So you want the least value of a whole number of n. Okay, so just double check that. There's also trial and error method. There's also the graphing method, trial and error. This is a fun one if you're panicking and you've forgotten everything. Then you just go to this part over here, trial and error. This part saves you a lot of time as well. And just substitute random values of n to see when you get a value that's less than 0.01. So you try 0.75 to the power of 5. If it's too big or too small, you adjust accordingly. Then try n equals 10. Then try n equals 15. Then try n equals 20. At that point, you will see that your answer is between 15 and 20, right? And then you start, I mean, there's only 16, 17, 18, 19 between that to test it. So you'll be able to see. A trial and error is a perfectly acceptable method. See, in the mark scheme over here, valid attempts. Again, you're getting marks for valid attempts, including graphical, use of logs, table method, just like I showed you, or trial and error. They accept that as a method. And where our marks were, we had that correct inequality for solving for p of x equals 0. So that part way at the beginning here. There we go. When we're calculating p of x equals 0, that method. Attempts to solve, aren't they nice? There's always attempts that you get marks for. So always show something, always try something. I think you'll always have at least a vague idea of what the question is asking. So you can attempt to show something and still get marks for that. All right, and then we would have gotten that, and you would find that the least value of n is 17. Again, check them. Check 16, check 17, substitute it in and make sure that you have really got the correct value there. And I think we don't have time for question 3, but that's okay. Hopefully you have a better understanding of how to approach these questions and binomial distribution. So that brings me to a couple of exam tips. I'll just go through these quickly. So first one, this goes for all tests, all questions. Don't round too early. Store your answers if you can, and make sure that you're using the full answer, as full as possible, if you're doing part B or part C. Make sure to check if the situation is a binomial distribution, and then remember to write it. X is binomially distributed with NP. That's going to get you marks. And show that you understand. Memorize the formula for binomial distribution. Hopefully you've seen it a couple of times now and it's not looking too scary. And yeah, show correct notation method as much as possible to get full marks. And if any of this was unclear, or if you wanted some notes or worked examples, there are many here. So if you go to learn, and then for each of the topics, today we were doing binomial distribution. These notes are amazing, I must say. There's definitions, worked examples, common mistakes to avoid, exam tips. Everything you could possibly need is in these notes. So just a reminder to use those as you're studying. We also have a homework assignment. It's depending on which course you're doing, if it's AA, SL or HL, or AI, SL or HL. There's a homework, just a small assignment from what we've done now that you can practice on binomial distribution. The class codes will be on the info page, which I'm going to send in the chat now. So hopefully you can see that. If you click on that link, it will take you to all of the information about the bootcamp and the other sessions that we're going to have, times, links, all of that, as well as the class codes to join. So they would look something like this: Exam Prep Bootcamp M26, if you use the class code, and there'll be homework assignments there. All right, any questions? I know that was a lot of listening, and hopefully it added some value and you learned something that you didn't know before. But do you have any questions you'd like to ask? All right, I see how to do the table on the calculator. I have a Casio. So I don't know Casio as well. I've just worked with TI Inspire and TI 84. So what I would recommend for that is actually AI. ChatGPT is really good at, for each of the different calculators, telling you what buttons you need to press. So if you just ask what what are the steps to create a table on a Casio? I'm imagining it's something very similar to setting up a table and a list. So if you go from home and new, something that looks like lists and spreadsheets, I would imagine. And then you add the information there. Can you find something like that on your Casio on how to add lists and spreadsheets? Look out for the keywords of spreadsheet or list, and it should be at menu. But yeah, it's very lucky that you guys are in the age of ChatGPT, because it's getting really, really good at maths. So it's a great thing. If you're unsure of anything, if you don't have a tutor or someone to help, or you're stuck, just to screenshot a question and say, what would an IBDP solution to this look like? Also on Exam Dojo, there's the help function, which is really good at giving you the actually IB aligned feedback and help. Great, you found it. And I'm glad it was helpful. I hope you guys are feeling confident about your exams and maths, and hopefully I'll see you at the next sessions. So our next session later today will be normal distribution, and then tomorrow we have 2 sessions. But yeah, all the information is on the info page that you want to join. And keep a lookout for some more scheduled sessions coming up in the next week. All right. Anything else? Any other questions? All right, hopefully see you later. And we've entered the void. Stop sharing. All right, see you later, and have a lovely rest of your weekend. Goodbye.